My name's Arthur Cole. My student number is C16406984. Sorry for this project being late. Unfortunately, I got held up in real life and I just couldn't get to it till now. But here's my final project. As you can see, I've got two VPCs and they're in US East 1. The reason for this is I used CloudPing Info, which is a website which measures users' latencies, and I know US East 1 is in Virginia and their main office is in Southern California, but they also have offices in Europe and Southern America, and I thought it was better to find a position which is equidistant and offers the best latency to all three offices, which US East 1 does. It's also cheaper than the Southern California US West 1, so I decided that was the best. And there's two VPCs, one for live production, so that's where they deploy, and a development and test subnet, which is just an identical layout which is used for testing applications and changes. And each of these VPCs have 8 subnets and spread over across 2 availability zones. So yeah, we just got public ELB and public ELB2, which is for the load balancer, and they're public obviously, and then AZ1 or 2, and then private web, private app, private DV on in A and B, basically. And yeah, for security details, we've got our load balancer security group, which just allows traffic in on 443, which is SSL traffic, so it only allows traffic in on using secure connection like HTTPS example, and accepts that from all sources. And you could also allow port 80 if you wanted to allow non-secure traffic, but that would probably be a bad idea in this case. And then we got web tier group, which just allows traffic on 8080, which is what the port that the load balancer will deliver traffic from the web to the web server on, and it can only accept from the ELB. App server similar, it accepts it from the application load balancer on 8080, and will only accept from the web tier and the application, and the application tier obviously load balancer. And then database allows in 3306, which is the MySQL connector port. And then we just four other security options. We've got network access control lists, obviously. So this will just allow for example, the web tier to block all traffic that doesn't come from the load balancer on the app tier and the app tier servers, and it will block all other traffic that's not on its whitelist. So you'll only add the load balancer, the web tier on the web tier, and the app tier to the web tier's whitelist, and so on. So it just means it's only accepting traffic from very specific sources. Host firewalls, you can actually use the firewall D in OpenSUSE, which is just in case your NACLs are misconfigured or something, it's an anti-layer protection basically. And then in AWS WAF, you can just deploy a WAF on your network. This will just protect you from some XSS attacks and stuff like that, and it's just an added level of protection. And then CloudTrail, so that audit, set your CloudTrail, back up your CloudTrail logs regularly and look at them and make sure they're ready for audit in case you do get breached. And then for encryption options, we'll just use the S3 encryption option and just store the keys using KMS. Similar with RDS, just use the RDS encryption and manage the keys again with KMS. For data in transit, the files are already encrypted, so you don't need to actually encrypt them again, but you can also use SSL search if you really wanted to, if it's an issue with that. But since they are already encrypted, transmitting them over the plane should be fine. And then for the instance details, we're just using OpenSUSE Leap 15, which is close to their OpenSUSE 12, and basically that's what they're used to, so there's no reason not to use that. And yeah, we're using 3 instances which are burstable, and they've got 8 gigs of RAM, which means their usage should be less than 50%, since they're using 3 gigs of RAM at the moment. And they're burstable obviously, so that will also help if your CPU usage boosts. For the app tier, we're using M5 4X larges, which are beasts, with 64 gigs of RAM, and which is double what they're currently using, so it definitely should be less than 50%. And they've got 16 vCPUs, but they're not burstable, it's just solid provided performance. You pay for all those vCPUs all the time, which is good obviously because there's a lot of CPUs on the app servers. And then for the database, it's 64 gigs of RAM, 8 vCPUs. It's a bit more powerful than their current setup, but if they need more, they can always upgrade. And yeah, there'll be 2 instances in that case, because a replica will all be created, and the 6 and 5, which is what they currently have. For the pointer the recovery point objective, that's pretty simple. You just need to create snapshots of the RDS every 4 hours or less, so that you recover the database. And since the servers and the app servers are stateless, they've got no unique data, they're only serving data from S3, Glacier, and the database, then all that's needed is we just use the custom AMI that's used to create them with autoscaling. That's all we need to back them up and restore them. And then for document storage, we're using S3 buckets. So, it's the S3 buckets will be all the static data, and it will just be stored for 3 months. After that grace period, it's said in the specification that the data won't be accessed nearly at all at that stage, but it still needs to be kept. So we can just use lifecycle policy to move that to Glacier, which is really cheap, and then it'll stay in Glacier for 4 years, 9 months, which is the rest of that 5-year period that you need to keep it for, and then you can just be flagged for deletion or review, or you can just delete them automatically. And we could also use, I suppose, instead of Amazon Glacier, you could use S3 buckets in frequent storage, which is another kind of sub-service of S3 buckets, which is just cheap storage, much cheaper than S3 buckets, but it's still it's still an S3 bucket, but it's a bit faster than Glacier lookups, which can take like 1 or 5 minutes. And then web tier requirements. Use autoscaling to make sure the bandwidth is between 300 megabits and 750 megabits a second. Use CloudWatch to notify them when. So use CloudWatch to stream your logs from the services to CloudWatch, and then you can just set an alarm on that when you get more than 100 HTTP 400 errors in the logs, just email the administrators basically. And for app tier, similarly, use autoscaling to manage, to make sure that the CPU doesn't go too high, and just make more instances when you need, when the CPU usage is too high, and delete them when it's getting too low. And for internet access is required, just using a customer gateway to create a VPN connection, and then you can just use that for updating and patching, and it's much secure than leaving them exposed to the internet directly. And then database tier requirements, so just pay for a provisioned IOPS SSD storage and pay for 22,000 IOPS approximately. You can always map that out, and then on the read replica, you only need to pay for general SSD storage, which doesn't come. You're not paying for the IOPS, you just get you just get those SSDs and whatever IOPS they can produce, and that's fine. That's all you need. For the replica, because you're not going to be accessing that often. That's only if it's a problem. That's only a backup. And then just high availability. You just use the RDS and set it for multiple availability zone deployment, which will just create a replica that mirrors the main database basically if there's a problem. And then no changes to the database. I wasn't really sure what they meant by this, so I just assumed you put the SQL, since they're both SQL versions of my SQL version is the same, you just use the same schema and then just import the data onto that. And then additional services, the customer gateway for VPNs access, like I said, and use CloudFront CDN just to serve content faster to the EU, South American, and the head office regions. It'll cache, like Cloudflare, cache, static contents and stuff, and that will just make it faster. And then I suppose cost considerations. Servers have been over provisioned slightly, but that's nature. You can't get the exact same as what they have, and they want more. That's fine, but not a huge amount, and it will still be cheaper than having on-premises hardware. And then autoscaling will deal with the rest, so you don't need to over provision constantly, which is a huge cost saver. And then here's the architecture diagram, which is also in my submitted file. Thanks. Merry Christmas.